And yeah, and now that we had like a pretty robust Grasshopper tool, we had the web tool that was working. This was what I had mentioned earlier, where these scientists over at Berkeley are now like rewriting the standards for comfort. Because originally the comfort model to deal with downdraft was based on blowing cold air on the backs of people's necks, which is the most sensitive part of your body for downdrafts, for cold drafts. And they were originally doing that because they were worried that HVAC systems, they could blow cold air on the back of your necks. They wanted to make sure that no one was uncomfortable for that. But of course, it's overkill for our problem, which is just cold air going past your feet. Our backs of our necks aren't nearly as sensitive as our feet are. And so the scientists over at Berkeley said, all right, we're gonna redo this, so that we have a better way of assessing this comfort. And they ran, you see there's a picture of their experiment in their climate chamber, which is a very nice looking climate chamber. Yeah. I mean, they like to brag about it, I know. But then they blew cold air around people's feet and now have a much better comfort model. And that should hopefully be in the standards within like another couple years. But thanks to us being open, they've shared that with us now. And
So we're in the process of updating our tool to account for their new model.
Yeah, so we have a web tool 2.0 now that has the new standards.
So I guess, so as a result of this study, what's the result? Is it that it's easier to heat and cool spaces, or?
The result was that we basically, because the only model that existed was using the back of the neck, we were overestimating the impact of downdraft. And so we were ending up with slightly more conservative designs than we needed to, basically. And so by incorporating their new model, it now makes that estimation more reasonable. And so some of the things that previously our model was saying, well, that might not be comfortable, actually turn out to maybe be okay. Because we were using a model that was more overly conservative.
Okay. And have you, I don't know where you are in this whole process, but you've incorporated this, now you're using it in some of your designs. Have you actually executed any designs and then gone back and sort of confirmed that, yeah, we did this, and yeah, we are seeing this?
Yep.
Not from the, so from the, we started the tool in 2014, we started doing this research in 2014. Mm-hmm. So we definitely have used it in a lot of our designs that are kind of under construction and just finishing, but design takes a long time.
Oh, yeah.
So we're just right now finishing up the second version of the tool, but even the first version of the tool, we really finished this like June-ish, May, June.
Yeah.
And so we've used it in design, but obviously nothing is built and we haven't been able to measure it yet.
Okay.
Wouldn't it be great if we were done, but.
Yeah, it's okay.
Well, we do have one case, one validation case we'll show.
Yeah.
Of at least of what we had to do before we had this tool.
Yeah, so we've gone back and looked at past projects to kind of say like, because previously when we wanted to look at this issue, we had to run a CFD model. Mm-hmm. And so we've gone back to some of the ones where we had that CFD model to say, well, how close is our tool to what the CFD model was saying, whether or not it's comfortable. So we've tried to do some validation in that sense.
Okay.
CFD being computational fluid dynamics, which is it's probably one of the most advanced things we do with the computer, simulations that can take weeks to run. Anyway, we'll get to that. We'll talk about that.
We can come back and maybe do the demo in a moment.
Okay.
Do you guys want to do?
Sure, we can do the case study.
A little bit of.
So this is actually that case study. This is a project that we just finished construction. Actually, we're punch listing it right now at Northeastern University, not too far away. So if you guys want to hop on the train and go to the orange line, the Ruggles stop, it's right there. And it's got this curved facade of sunscreens. And then behind it is actually a pretty traditional dumb curtain wall, for lack of a better word. It's mostly all glass in the office area. Okay. And we had, if you go back, well, it doesn't matter actually. So we had in our design, we had a bit of miscommunication that had happened with our engineering partners for this. And so when we got to DD, we realized we basically had drawn two pieces of glass in our drawing. And we'd set the goal of eliminating perimeter heating. And so they hadn't put one in. And so we had this design that wasn't going to be comfortable. It's an all-glass building. It's in Boston. It's pretty shaded. And it's a double pane glazing and has no perimeter heating. And so we were like, okay, well, we were just starting design development. We're going to have to do something to rectify this. We're either going to have to add in a heating system or we're going to have to change the glass, kind of budgetary-wise. And so we did an analysis where the contractor priced both options. And we did, at the time, because we didn't have this handy tool, we did a CFD model, which is, I think, the next slide. Mm-hmm. Yeah, we did a CFD model to understand, would we be comfortable, kind of current design? And we had, so the blue is kind of different shades, or the different contours of uncomfortability. And so the top one here, the person sitting at the desk, about 20 to 30% of the people would be dissatisfied. So that was above we decided to use the 20% threshold for that. So that was above our threshold. We looked at it with the 30%, or with the triple glazing, sorry, and it goes down to about 10%, 10 to 20%, right on that threshold, which is the lower. So that's with the double glaze, and that's with the triple glaze.
Okay, so here you're seeing this, is this the threshold?
Yeah,
This one here?
basically. That's the 10%, and then this one here, this lighter blue is the 20 to 30%.
I see, so this is the 20 to 30.
Yeah.
So this,
So the person is clearly in this.
Clearly,
Yeah.
clearly it's going to be a problem.
yeah, but here you've minimized it to,
Yep,
so that it's
exactly.
not there. Okay,
And you can see in the plan that it's really just around the kind of mullions.
yeah. Okay.
And while this worked on this project, just so that you guys understand why don't we just do this for all projects? This CFD study, I think it was around somewhere between $10,000 and $15,000 or something. It was a long. I mean, these are really long simulations to run. They're
Yeah.
so many like variables. You really need like PhD
took us-
experts.
I think we started talking about it in like July or August, and we got the results in like October or November.
Wow.
So we set off at the beginning of design development knowing we had this problem we needed to answer. It, and so they decided CFD, the computational fluid dynamics, would be the best way to do it. But it takes a long time. So in the process of it, it's not something you can do in every project. Like a lot of projects might be done with the design phase by the time you get that answer, in addition to the cost.
Yep.
But it's nice because we had as an example we can then validate.
But it was so
against.
expensive and so on, but I mean, $10,000 to $30,000 study is a drop in the bucket for how
the whole,
much of a
yeah.
project? I mean,
Oh, the budget?
Yeah.
It's
hundreds
like-
of millions of dollars or
yes,
something like
yeah.
that? Yeah.
Yeah, I mean, it's true. Yeah, it's
Yeah,
true.
so-
We're nowhere
Yeah.
near the cost of what
Right,
the
yeah,
actual.
no,
Well,
absolutely.
what the big thing that was at stake was this was the project where the extra pane of glass was a tenth the cost
Yeah.
of the perimeter heating
Yeah.
system.
Because we
That
actually
was-
went and priced both of them.
Yes, it was definitely
and so,
worth it.
This is using our tool. The same analysis would have taken us 3 minutes, if that. In addition to going to the triple pane, we also decided to raise the sill height of the window by a foot to kind of combat that downdraft. And so you can kind of see from the screenshots there of our tool that doesn't have the sill raise, but you can see that it went from the orange line was the previous design with the double glazing, and the blue line, which is now below the comfort line, it sort of moved it into the comfort threshold.
Okay. And again, 20 was, so here's your 20.
We were using the 20% threshold.
So that line right there.
Yeah.
So these guys, again, at, whatever,
Yeah,
less
they were
than
about
2
2
feet.
feet. Yeah,
trying to draw this sideways, but yeah.
that's okay.
Yeah, and maybe just to explain that a little bit. So with the way that the standards are being written are such that 10% is what the threshold is drawn out for full body discomfort, but they're making it a 20% dissatisfaction at the ankle level. I mean, I guess the assumption is that maybe we can tolerate our cold feet more so than we tolerate our whole bodies being cold.
So we just need like ankle, what are those things, leggings that used to go up to your knees
Yeah.
or something like that?
Yeah.
Office,
Yeah,
What's
bring
the
back
word?
the 80s.
because leg warmers. We need leg warmers, office leg warmers.
Which is another way you can deal with thermal comfort.
That's
is You can
right.
change your clow value.
Yeah.
Or we
Yeah.
could have everyone get up and do jumping jacks.
Those are inputs you can change if you know that they're going to happen.
I'll take that, okay.
And so, yeah, the project, that's just sort of the final facade. And we're able to execute it without having to have the heating.
Awesome.
These are just some useful links. The link to the current tool, the version 2.0 beta, where all the code's kept, and to the Center for the Built Environment and Ladybug, just because so much
We
comes
use
from
them
it.
heavily.
Yeah.
Yeah.
Awesome.